design a PIFA antenna. To design and simulate a PIFA antenna. As you know, PIFAs are commonly used in mobile phone because of their compact size, easy integration, and good specific absorption rate properties. Because the available volume to space of the antenna is small compared to the wavelength of the antenna. We'll be designing for a typical mobile layout and we'll be using a substrate of FR4 with dimensions which is will see on. Because we are not designing for a specific frequency, with this toolkit, we can actually design any type of antenna as you will see. So as we proceed, I'll show you how to go about this. To start, we need to first open our HFSS program, which I already opened. If you open your HFSS program, usually this is the front page you see. Sometimes there is an additional screen on this side, but today is not here. So that's where our HFSS toolkit, antenna toolkit design is. So to bring that up to the screen, all you need to do is click on view and you see ACT extensions. If you click on this, you see it will bring in the ACT home, of which we're starting our program. Here, if you launch, next thing, if you click on a launch wizard, this will open another page, kind of another screen, where you now select what kind of design you want to do. So for our design today, we'll be using HFSS Antenna ToolKit, and when we click on this, it will open another page of the wizard where we will now have to select what kind of antenna we want to design. Take that took quite a bit. So try to open the page. Yeah, that took quite a while. Anyway, now we are here. You can see that we have our HFSS Antenna Toolkit page now. From here, you can select any kind of antenna you want to design. We have antenna types, a bow type, conical spiral, custom dipole. So you have all kind here. You have dipole antenna, we have LX, we have on antenna, we have a PIFA, we have monopole, and we have patch, planar spiral, we have a slot antenna, all type. But today we'll be going for the PIFA as planar inverted F antenna. So here, if we click on this to open, we have under the antenna toolkit PIFA design, there are three types of design that you can build with this. We have the PIFA with shorting pin, we have PIFA with shorting plate, we have PIFA planar inverted. So I'm interested in this planar inverted F antenna today. So if we click on this, it will now open give us the setting place. On this side of the plane is where we'll define our parameter. For today, I'll be designing for 3.5 gigahertz. It's a standard 5G uh, antenna frequency band. So going for 3.5G. Normally, when you are designing, you can just click on synthesize after putting certain value. Then the automation, this thing will calculate all the other variables. But first, you can specify certain other value, and so that it will help in designing that. So here I'm going to use, I'll, I'll come back to this. I've selected my 3.5 gigahertz band. I'm going to use FR4. I want to use FR4 for as my substrate, and I want to use a, a substrate height of 8 mm. Or I want to use a substrate height of 9, let's say, okay, 0.8 mm. So here you observe that these are in cm. So if I'm using a substrate height of 8 mm, 8 mm, so it means I will be using 0.08 cm, and because yeah, it's cm. And here, if I want to choose my substrate dimension as well, you observe that a typical mobile phone has a width and length of about a width of between say 60 and 100 mm, and the length or height of between maybe 100 and 150. So, but for this, we'll just pick a standard, say 150 by 75 mm. And so the 150 mm will give us a 15 cm. This is height of 15 cm. And we have a substrate, uh, no, our substrate height, sorry, was 0.08 mm, which is 0.0. Our substrate height is 0.8 mm. That's what I'm using, which gives me 0.08 cm. We have a dimension, x dimension, which is our width. I'll be using 75 mm, which is same as 7.5 cm. And my substrate dimension, the height, I'll be using 150 mm, which is 15 cm. So I've input these values. I still need to define my antenna dimensions. For this, I can say, okay, let's synthesize and see what synthesizing actually do. It automatically calculates other variables based on the values I've put. If I synthesize, what it's telling me is that my optimal design will need these parameters to function. If you look at the variables here, it's giving me an antenna length of 1.55 cm, antenna length 2. If you look here, you see like a default setting that explains what these values mean. This is my antenna, that's the radiating part of my antenna, and this is an F antenna. You see the shape of F here, and it's inverted. That's why it's called inverted F antenna. And because it's using microstrip, is called a planar inverted F antenna. So here is my antenna length 1, which is this 1.55 cm, which is 15.5 mm. And here is my length 2, and this is my antenna trace width. This is the width of my antenna. And I have antenna offset, that's the distance between this length 2 and my feed here. So having synthesized this, you see it automatically changed my dimensions here as well, because it's trying to give me an optimal, but I can actually change this value to what shape and size I want. But let's just, for the time being, I set this default. We'll still have the opportunity to change everything back from the schematic that is shown. So if you click on finish, the HFSS will now set out to create your design for you, and you, by doing this too, you would have prepared some of the simulation plots which we'll come back to. So we just wait for it to execute the current step, create our design, as well as some sets of other parameters for our plots. So we just hold on a while and see what happens. The beauty of the Antenna TootKit is that it simplifies our work by setting up some of our design plots. If you look at this side, it's already done most of the work for us, because the our uh, when they finish, I'll explain again what's going on here. This is our standard design. This is our standard design. You see our F antenna, the toolkit automatically include our probe here. This is our the part of the antenna that is connected to ground. This is our ground plane, and this is our probe where our inputs will be. The input to the antenna will be. So if we look at the if you look at our antenna, we discover that our probe will be here. So all our parameters are being automatically set. So all we need to do now is verify and see if our antenna is the way we want it to be. If you observe here too, you will discover that we have our patch, our antenna on top the substrate, and our ground plane is above, under, while our is below our substrate. So, for example, if you're not satisfied with this display, you can change all the parameters here. All you need to do is just go to HFSS. You see your design properties. So all the properties, all the variables design that we saw in the toolkit are all displayed here. For example, if you can change the substrate height, the substrate height, You can change the width of the substrate, which by extension is the antenna as well, because the substrate and the ground they almost go together, and to whichever value you want. But for the purpose of just learning, we're going to leave these values the way they are. So the next step now is we now run to see a validation check to see if our design passes validation, if everything is okay. So if you click on that, you run the validation and tell you that a check complete, and with this good shows that everything is okay. So we can now proceed to do a complete simulation of our design. So if you go back to HFSS and you now click analyzer, this will now set out to do a complete simulation analysis of our design. So if you click on this, sometimes it takes a while for it to be completed. So here you have a show message and show the progress of our design. So just so we have our message now. So we have here the progress of the simulation, and this shows any message as per any message as it relates to the simulation, the progress of our simulation. So we just wait and let the simulation complete. Then we'll look at the results. We look and analyze the results. So as you can see, our simulation is complete. So now we'll now proceed to investigate our result. We have series of results here. Here we have a far field gain, a 3D far field gain plot. So if we click on this, we see that this is our 3D plot of the far field result of our simulation. Here too is a 2D plot gain of the listing. It's called that we have our highest gain at this point and the maximum of say maximum of 3.7 there. At this point we have different simulation thing. So here we have a 2D two-dimensional view of our game. This is what we have. And on this side, we have our total gain. This dark one. So on this side, you can get a plot of your results of the simulation result. So we have the far field view, and here we have our return loss, which shows our because we designed for 3.5. You can see our resonance here at 3.5. Which is the is as a result of the convolution of the PIFA and the dimension of the radiating element. So this is our return loss and our input impedance from this plot too. And you can see the nice input. So overall, how to use this demonstrates how to use HFSS Antenna TootKit to design any type of antenna fast and simple. As well as demonstrated here for a PIFA antenna. I hope you learned something from here and it helps you in developing your antenna. Thank you for watching our video.